Hi there, I'm Amy Jensen, and in this video we are going to review lots of problems on simplifying rational expressions. So you asked me to review the steps for these. So there are three different types of problems: simplifying the expression, and then we have adding and subtracting, as well as multiplying and dividing. So if you need to review these steps, you could pause the video and read through these. But basically, the first thing you always want to do is identify what type of problem you're tackling before you start. When you're adding and subtracting, the most important thing is to find the common denominator, and then we're going to combine our like terms and then factor and simplify. When we multiply and divide, we want to factor, then cross-simplify to eliminate the common factors, multiply and then simplify at the end. And on some problems, you'll be asked to identify the excluded values. That's where the denominator is equal to 0, and therefore the expression is undefined. So remember, you want to find your values before you cross out common factors. So here are 12 problems that you might see on a test. Pause the video, write down the problems, and try to work them yourself, then come back and see how you did. Careful, some of them are trickier than they look. Okay, let's see how you did. So the first three problems, you're just asked to simplify and identify any excluded values. So when we simplify, we need to factor the numerator and the denominator. The numerator is a perfect cube, so we'll go ahead and factor that. And then the denominator, we want to take out the GCF. Always look for that first. And then we can factor the denominator. And those two trinomials will cancel out or simplify. So we're left with x plus 3 all over 5. Now I know that when I factor a perfect cube, that trinomial in the factored form will never factor any further, and it will give me a complex answer with i's. And we won't have any kind of complex answers in this unit at all. You just want real numbers. All right, so here's number 2. This one's a little tricky because we have 9 minus x squared. So what do we do with that? Well, we can factor out the negative, and that allows us to switch our variable and our constant around. And what do you bet? That's going to cancel out with something on the bottom. So x squared minus 9, that is the difference of two squares. So we want to factor that. And then we'll be able to simplify that x plus 3. So when you get your final answer, don't forget that negative that we factored out. So our final answer here, we can leave just like that because the directions said that we could leave our answers in factored form as long as we simplify completely. There are actually several different ways to write this problem, so you could also write it 3 minus x, which is just distributing that negative through the numerator. Either of those answers would be acceptable. So the excluded values, remember, we need to check that before we simplify. So we want to use the factored form of the denominator before we simplify, set those factors equal to 0, and solve for x. So we get x equals negative 3 and x equals 4. All right, on to number 3. So let's look for a GCF. And for some reason, students really struggle with this problem. And it really is fairly easy to factor. We can take out a 4x squared in the denominator. And of course we have a 4 on the top. But what do we do with that x to the 5th? You might be able to simplify that just remembering your rules of exponents. But remember, you can also rewrite that as x squared times x cubed. And that might help you see it better with why it simplifies. So I'm left with x cubed all over 3x plus 7. And again, when I'm finding the excluded values, make sure you check before you simplify. So that x squared that we factored out, we set that equal to 0. And then we also set 3x plus 7 equal to 0. So we have two different excluded values. A lot of students forget the x equals 0 as an excluded value. So moving right along, number 4, first thing with these problems, you want to identify what you're asked to do. So this, we are subtracting. So when you're subtracting, first thing I would do is write all the binomials in parentheses. And that helps me remember to distribute the negative. Now in this case, we have the same denominator in both of our fractions. So we can just rewrite the fraction all as one fraction. Distribute that negative, and then we're going to go ahead and factor and simplify at this point. So when you're adding and subtracting, you really want to get a common denominator, then write your equation all over one denominator. So we're going to factor the numerator, factor the denominator. The x minus 5 factor cancels out. So we're left with x plus 4 all over x plus 3. Now we were not asked to find excluded values on the rest of these. All right, number 5. So let's factor the denominator. These are different denominators, so I need to find the least common denominator here. So the least common denominator in factored form is just x plus 5 times x minus 5. So the expression on the left is fine, but the second one I need to multiply the top and the bottom by x minus 5. And then again, now I have the same denominator, so I can write all of that as one fraction. And then I'll rewrite this down here. So I'm adding in this case. So I'm going to distribute the 3x minus 15. And then I can combine my like terms. And then I will simplify further by factoring the numerator. Now, if you saw that you could skip to that next step without writing down all of these steps, that is fine. I'm just trying to show what's going on here so nobody gets lost. But you do need to show all of your work on your test or quiz. But if you went from the expression on the left all the way to the expression on the right, that's completely fine. So we're going to simplify the x plus 5 factor, and we're left with x minus 3 all over x minus 5. So number 6, again we're adding. Let's identify the least common denominator. So in order to do that, I want to factor. So what is the least common denominator? Well, I need x plus 3, and I need an x minus 2, and an x plus 1. So I need one of each of those factors in the denominator. So I'm going to write my least common denominator here. I already have x minus 2 in both of the fractions. So for the first fraction on the left, I just need to multiply that 2 times x plus 1. And the one on the right, I need to multiply 3 times x plus 3. And then I am good to go. So I'm going to distribute the 2, distribute the 3, and then I can combine my like terms. Again, it's all over that same denominator, so I don't need to write it again over and over. And nothing is going to simplify any further than that. So I'm allowed to leave my answer in factored form So I don't need to multiply that whole denominator together. And as a matter of fact, don't do that because you're likely to make a mistake if you do. As long as your teacher allows you to leave it that way, leave it that way. Okay, 7's a little tricky. Again, the second denominator, it's almost the same, but not quite. So when you see it reversed like this, we need to factor out a negative. So if I factor out a negative from that second denominator, that's going to allow me to switch the order around and get x minus 3, so the denominators match. Now, I'm already subtracting in this problem. So what happens there is that I can write x minus 3 in the denominator, and I'm going to have a negative minus a negative, which will be a positive, so 2x plus 5. So you're almost guaranteed to have one of those types of problems on your test. So you really need to know how to do that, and they're really easy once you have practiced it enough. Okay, so now we are multiplying. And on your test, you need to be really careful to pay attention. Are you adding, subtracting, multiplying, dividing? Because they'll all be mixed together. So in this case, we're multiplying. So we need to factor first. And when we're multiplying, we can cross simplify. No need to multiply out all of the expressions if they're going to cancel out anyway. So let's go ahead and factor everything. So that x cubed minus 8, that's a perfect cubed. So remember your rules with SOP, SMS. Signs are same, opposite, positive. And then in that trinomial, I square, multiply, square. So, and again, I know when I factor a perfect cube, that trinomial will not factor anymore. So don't waste your time trying to do that. So I'm left with x squared plus 2x plus 4 all over x minus 7. So next one, number 9. All right, this one we're dividing. So remember, when you're dividing, you want to flip that second fraction and then change it into a multiplication problem. So we're going to switch it to multiply, and I'm going to rewrite that with the denominator now in the numerator. And now I'm going to proceed like I did with the other multiplication problem and just factor, cross simplify, and then multiply across the top and then across the bottom. So let's go ahead and do that. And of course, if you're feeling good about this, when you flip your second fraction, you can just jump to this step. But again, I just want to make sure everybody's clear on exactly what I'm doing here. So now I'm factoring x minus 9. Let's see, x plus 1. Take out that GCF. Oops, and I need to take out a GCF in the other denominator, so I can factor out a 2 there. Let's do that real quick. Okay, and now we can cross simplify, meaning I can cross out one factor in the top with any one factor that matches in the bottom. Now I'm going to combine my terms, just multiply straight across. So I end up with x minus 3 times x minus 9. And then don't forget about those constants there, the 2 and 3. So 2 times 3, I get 6. That's a really common mistake. They just get kind of lost in the problem. So make sure and go back and find all those numbers. Make sure you've simplified them when you can and multiply them all the way through. Okay, this is another kind of division problem. That's all that is. It looks super scary, but it's just division written as a fraction. So the first thing we want to do is rewrite that as a regular division problem. So I have x squared plus 9x over 7x. That's one fraction. And then I'm dividing by the other fraction. Okay, so now I'm going to switch it into a multiplication problem by flipping the second fraction and multiplying. And I know you are probably going to skip several of these steps, so that's okay, especially if you're feeling good about all this. So when you're showing your work, you just need to at least show from the next step on. So let's see what we can do once we factor this. So when we factor x squared plus 9x, all that I can do with that is take out a GCF, because it's plus there. And let's see, so now we have the wrong order again from what we're used to. So if we want to flip that around, because I know that that's going to be a difference of squares, which will become x plus 9 and x minus 9. And that x plus 9 will cancel out with that factor above. So I definitely want to write it that way. And then that negative, just think of that as a -1. So we'll cross that out, and then our x's can cross out. And just so we don't get confused about what happens to that negative, we're going to rewrite that as -7/7, or 7 over -7. It doesn't really matter. The 7's will cancel out. I'm left with a -1, so I can write that as negative times the quantity x minus 3 all over x minus 9. Or you can distribute that negative just on the top and get 3 minus x all over x minus 9. Either way, I would just leave it with the one on the left because you're not required to change it, and then you're not liable to mess anything up. Okay, 11 and 12 are a little bit tricky. They look easy, but again, we just have the reversed order, so you're probably getting to be a pro at this part. So I'm going to factor out a negative. So now what happens with the numerator? That's what people screw up. So don't forget that's a -1 in the top. If there wasn't a negative there and you factor out everything in the numerator, you would have a 1 in the numerator. So don't just ignore that and put negative x plus 3. It has to be -1 over x plus 3. And then number 12, so I can factor this as a perfect square. So x plus 4 times x plus 4. And then the denominator is the difference of squares. So I'll end up with x plus 4 all over x minus 4. Now, that's it. That's all I can do. I can't simplify that any further. Students sometimes like to cross out the x's or simplify the 4's, but you can't do that. That's breaking up the family. You can't simplify that fraction any further. So leave it like that and know that that's in its simplest form. So that's all 12 problems. How did you do? You can do this. You just need to practice. If you can do all 12 of those, you can do well on the test. So the next part is solving, and we're going to cover those in another video just so it doesn't get too long. So click in the link below. Thanks for watching and have a great day.